In this question it says the diagram shows a tetrahedron. Okay, a tetrahedron is like a pyramid, but all the faces are triangles, and this one has a triangular base there. Okay, it says AD is perpendicular to both AB and AC. So perpendicular means at right angles, and we can see that here. So AD, right, the height is perpendicular to both AB and AC. I'm looking at it on the diagram. They've also given us some dimensions, which are also on the diagram. AB is 10 centimeters, AC is 8 centimeters, and AD is 5 centimeters. And those values are on the diagram there. They've also told us that the angle BAC is 90 degrees. So BAC is 90 degrees. That's that right angle there. It's on the diagram as well. So we have a right angle triangle as the base, a right angle triangle on this side, ADC, and a right angle triangle on the far side, ABD. And what they want us to work out is angle BDC. That angle BDC is this angle at the top here, and they want us to give the answer to one decimal place as well, as you can see. So this angle at the top is BDC. Okay, going from B to D and then D to C, that's the angle there. I'm just going to redraw this triangle as if I was looking at it straight on. So if that was the triangle BDC, this is the angle that I want to work out. What do I know about this triangle in terms of distances? Nothing. I don't know the length of BD or CD or BC. Right? I don't know any of those lengths. I need to think about whether I can work them out. Looking at these and the distances that they've given us, and what I know about the other faces, all the other faces are right angle triangles. Right? Once you have right angle triangles, you think trigonometry or Pythagoras. There are no angles given at all anywhere, so I can't really use trigonometry. Pythagoras, can I use that? Okay, let's consider this triangle here. Okay, ADC. What do I know about this triangle? This distance here is 8. Its height is 5. I can work out CD. Alright, I can use Pythagoras. 5 squared plus 8 squared, and then I'm going to square root the whole thing. That gives me the distance CD. If I do that, I'm not working it out exactly. Right, I'm just going to leave it as a square root. If I do need to turn it into a decimal, I could work through that. So CD is 89 centimeters. So it's the square root of 89. If I just put it on this diagram here, let's do this with the other triangles as well then. So if I look at ADB, okay, if I put in its distances, AB is 10 centimeters, AD still 5 centimeters. I'm going to go through the same process to work out BD. BD is going to be 5 squared plus 10 squared, and then square root all of that, and that's going to give me the square root of 125. Okay, I'm not going to work it out as a decimal. Let's look at the other triangle that could help us, the base of the tetrahedron, ABC. Okay, so ABC, we know that AB, this distance across here, is 10 centimeters, and AC is 8 centimeters. So I could work out BC or CB, 10 squared plus 8 squared, and square root all of that. That's going to give me the square root of 164. And again, putting it on the diagram here, I'm going to put it on my triangle. Alright, so I have a fair bit of information here. I need to think about how I could use this information to work out the angle, and this should come to you fairly rapidly. Okay, what I'm going to do is I'm going to think about what I want to work out. Alright, and I think it's the sine or the cosine rule that I need to use. Let's go through this. So I have the opposite sides, small b, that opposite side, small c, and opposite big D is D. I want to work out this angle at the top here, D. That's what I want to find. I know that angle and all the other sides. I know right now that I want to use the cosine rule. Okay, the cosine rule, if I rearrange it for this, so I have D squared is equal to B squared plus C squared minus 2BC cos D. You need to remember that formula and make sure you are able to use it. I'm going to substitute for B, C, and small d into that. Okay, so if I square a square root, the square root just disappears. So this is going to turn into 164. So the square root of 64, 164 squared is just 164. The square root of 89 squared is 89. The square root of 125 squared is just 125. And then I'm going to write in all the other values of B and C over there. D is the angle that I want to work out, and I have cos D at the end. I need to rearrange this equation. So the first thing I'm going to do is I'm going to get rid of the 89 and the 125 from this side of the equal sign and chuck it over to the other side, so I get minus 89 and minus 125. If I work out that maths, that works out to be minus 50. On the other side, remember, and be very careful with this minus sign, I still have minus 2 root 89, 125 cos D. You can start working this on your calculator, right, by dividing by 2 root 89 root 125. You could type that straight into your calculator. We've got this here. Your calculator is going to tell you that this is equal to 0.237022, and then you need to inverse cos this. Make sure your calculator is in degrees mode. Inverse cos that value. Use the answer key to help you so you don't have to type in all the numbers, and you're going to get 76.2891. Remember, the question asks you to give the answer to one decimal place. So if I chop it off there, the next number along is an 8. That 2 is going to turn into a 3. So my final answer is 76.3. This is a really long question, right? There's a lot of learning potential in here, and you are very likely to get a question on the sine or cosine rule. And this is a good question to make sure you practice, you know, and you understand completely.